x is equal to, which I have not sketched yet. Now I'd like to know what cosine looks like as a sketch. And I'm going to go back to the unit circle. I thought unwrapping the unit circle. And as I unwrap it, this time I'm looking at, by definition, let me put a theta here so you will not confuse what I'm doing here. The definition is x. That's the definition for cosine. So all I need to do is, with your help, go to the unit circle and take a look at it. Guys, again, my major points in 0, ordered pair corresponding pi over 2. Up here, 90 degrees, 0, 1. Out here, of course, it's pi. -1, 0. Down here is 3 pi over 2. 0, -1. Now, the grid that I'm going to sketch this cosine graph, we'll accept this as your parent graph. It's going to look like this. So guys, again, we'll take the critical numbers from the unit circle, and my critical numbers for 0. Again, pi over 2, pi, 3 pi over 2, 2 pi. If you take a look at the y coordinates, yes, looks like from 0 up to 1. Also, I see a -1 and a y coordinate over here. That should be enough. Philip, here we go. I'm looking for this time x, not the y. I'm doing cosine. Well, notice at 0, my x coordinate is 1. That says you're going to start the graph then for cosine at 1. At pi over 2, up here, my x coordinate cosine is 0. Down here on the axis. At pi, which is here, my x coordinate is, of all things, -1. That means I need to drop down at pi to a -1. 3 pi over 2, 0 for the x coordinate, cosine. And finally, when I reach the 2 pi, 1 complete revolution, I'm back up at 1 for the x coordinate. Is that true? Connect. Something like this. For 1 cycle of the cosine graph. You saw the sine graph before the break. You saw the cosecant graph before the break. Now I'm done cosine. Guys, this one, and you got to keep in mind this is an infinite number of cycles. By the way, as I talk about this, keep in mind also there are cycles to the left. It goes forever to the left and right. I'm going to focus on that one red cycle for the parent graph. Domain, so when they ask for the domain, they want to know all the cycles. That will be a -infinity to infinity. Range, the up and down, though, it drops down to a -1 and goes up to a 1. What else I should do here? That's domain, range. Beautiful. Now, some of my students are doing this already. They're in that textbook, they're reading, they're seeing all the vocabulary involved here. When I talk about the cycles here, and the infinite number of cycles, they also start mentioning some vocabulary. First, they may ask you on a graph of this sort, what is the amplitude? And all they want to know is what is the highest point from the axis that the graph goes up. And in my case, it's 1, so the amplitude is to be considered as 1 for the cosine. In fact, I erased sine. In fact, if you look back at sine, I think the highest point was also 1 for the amplitude. They will also be asking me, when I start doing transformations especially, what is the period of the graph? And I'll describe it for right now, and some of my students came in and they had formulas to find this. But right now, it's just a point at which, if I wish, I could pick up and draw another cycle. So the way mine looks, could I pick up here at 2 pi if I wish, and draw another cycle if I wish? So we'll accept that 2 pi as the period number. That makes the values repeat for the graph. So I got domain, range, amplitude, period, and I'll accept that for my parent graph. Now let's do this. Why not? This is beautiful. What trig function would be appropriate now for me as an instructor to do next, since I have cosine there? Secant. What's the relationship between secant and cosine? 1 over. They are, absolutely. They are, this guy's in blue. Secant is equal to 1 over cosine. That's one of our identities. Which means, in essence, they are reciprocals. So I just need to go through on this red graph and do reciprocals to see what it looks like. And then we'll see what the secant graph looks like altogether. Guys, my first point is up at 1. I need the reciprocal of that. And the reciprocal of 1 is 1, so it stays there. Pi over 2, got an issue. At pi over 2, my cosine graph is at what, 0? And we've already decided from before the break, 0 has no reciprocal. So there's an asymptote involved here. -1 here at pi, the reciprocal, not the opposite, the reciprocal is, what's the reciprocal of -1? -1 stays right where it is. Whenever it's 3 pi over 2, it's right on 0 on the x-axis, and we already decided there is no reciprocal for 0. Math. Another asymptote. And finally at 2 pi, I'm up at 1, and the reciprocal 1 is 1. And guys, this will give me, for correct, the graph of secant. So I'm surprised I've got 4 of these out of the way tonight. Now connections, I don't think we need much here. From 0 to pi over 2, I would think, I think you would do this also, I think the graph must do something like this. And follow that vertical asymptote, but not touch it. Make sense? Next, I'm going to start mixing quadrants here also. Next, I'm from 90 to 180. That's quadrant 2. That's from here to here. That's in quadrant 2. And I'm doing secant, or trying to connect here. And I notice, guys, from here to here, to find out what's going on, I'm in quadrant 2. What is cosine or secant? What is the sign attached to them if you're in quadrant 2? Where cosine is x, what is x in quadrant 2 for any point? Is it negative? That says my next piece of my graph should be below. It's negative, below the x-axis. Well, I have no choice then. To be below, it's got to follow that asymptote, but it's got to come up and pick up that point. This is quadrant 2. That's the way the piece looks in quadrant 2. Quadrant 3 is from pi to 3 pi over 2, from 180 to 270. Now, if I'm in quadrant 3, I'm doing cosine or secant. What's the x coordinate if you're in quadrant 3? Negative. So you stay below. Negative. Just turns and does something like that. Finally, I'm over in quadrant 4, between 270 and 360. Now, if I'm in quadrant 4, the x coordinate is positive. That means my next piece of the graph should be above. I have no choice then. It's got to be above and follow that asymptote. That little piece looks like that. Let me step back and look at it. Isn't that strange? Now, what I'd like to do, with your help, we don't have the cycle that I want you guys to know as a parent graph. I would like to, let's do this. I could either take it out here to the left and complete the graph that I want, or I could take it out to the right beyond 2 pi and complete the graph out there. Let me go to the left. on this one. So we'll go over to a negative pi over two. Anyone tell me, what do you think's happening at negative pi over two? I heard there's an asymptote, another asymptote here. Negative pi over two. And what do you think might happen over there in terms of, I need a piece of the graph, I don't have the graph here in this little section yet. Where do you think the graph is? Where's the little piece? And over on the left. Do you think it's doing this, connecting here and going up like that? Where that asymptote? And this one, of course, we did earlier. Not supposed to touch that. Guys, these two pieces, I want two pieces on that graph here. These two pieces should be symmetric. Mine are not, but they should look alike. One's opening up, one's opening down. If I done it over here, Philip, if I extend it over here, I think the next point over here would be pi over two. I think. And that would be an asymptote. And if I had extended over there, the piece would do this. That's what we want. We want a full cycle. Now, which one do we accept here in this class for a parent graph? It's going to be up to us. Would you guys prefer to know these two and let that be your parent graph, which you could, or would you prefer these two? I need one opening up, one opening down, and I'll consider that the full graph. Which one should I accept? Or which one would you guys prefer? Because if I ask you to draw a parent graph, Nima may say, Professor, I'm going to draw this one from my parent graph. I can't count wrong. He's correct. And then he's going to do his transformations on this. Right? And then all of a sudden, Jonathan says, no, Professor, I like this one. That's my parent graph for secant. And then he will do his transformations on these. It's up to us. So guys, at least it looks like that, but right now for us, I'm going to do this. You will not be confused. I'm going to have my cycle to look like this. I need one piece opening up, one piece opening down. Yeah, I'm going to do this. Why not? I'm going to erase that and have that as my parent graph. Which is 3 pi over 2. Okay, I would accept that. Now, would I get angry if I say draw this on a sketch next week, and you may decide, no, Professor, I want to use maybe another cycle. It's up to you. I'm going to use this, from negative pi over 2 to 3 pi over 2. And that acts as my graph in blue there for secant. Now, with that one cycle staring at me, I got some information for you. This information, I think, was for the cosine graph. We did that earlier. So that information is gone. That was for this, cosine. Now let's go through secant and try to identify a few things. Guys, the domain of this graph, Barbara, you and I had a conversation at the break about domain. Here goes. Anyone tell me, based on what I see up here, a good way to show, I see some asymptotes. And the way I've sectioned mine off, I see one here, negative pi over 2, positive pi over 2, is it 3 pi over 2? Were all those asymptotes? So what would be a good way to write this up to include all of them? Because they want all of them for the function. They want to have in mind a formula. Someone gave me a formula, I think, for the break for the other one.
2n plus 1 over 2.
Oh, hear that? Okay. Tell me again.
2n plus 1 over 2.
2n plus 1 over 2?
Yeah.
Or by you're saying x cannot be. Here goes. 2n plus 1 over 2?
Pi.
Pi. I got you. And I'm assuming you're going to say let n be an element of the integers.
Yeah.
Again. Now, he came up with that formula. We tested just for a few of the integers. try zero. Zero is an integer. If I put zero into your formula for about, you're gonna end up with that term dropping out. You're gonna end up merely pi over two. What is there sure enough at pi over two in asymptote? We'll try maybe one. That's another integer. If I put a one in here, you're going to end up with, replace n by one, you're going to end up with three pi over two. Was there an asymptote of three pi over two? We'll try negative one. Just find a few integers in your formula. Put a negative one in here, guys, that's a negative two plus one, that's a negative one, I guess. It'll be a negative pi over two altogether. Was there an asymptote of negative pi over two? The guy has it. That will give me all of the locations of the asymptotes on that graph. This is for secant. Thank you, thank you. Now, how about the range? The up and down makes it a little bit easier. Let's see, what do you guys? Negative infinity is dropping down forever. Up to negative one, including, and then jumps up here. What was that, one? Through infinity. That's the domain, range, finished up. Adrian, here goes. I will throw some vocabulary again. They also want to know what the period is, let's call it P. What the period is, at what point, based on what I've done here, could I, if I wish, repeat and draw another cycle? What number would you give me that I could do that?
2.
And I'll accept that as the period number. What do you think?
3 pi over 2.
Okay, well, a beautiful, beautiful, hang on, oh, I got you, I see what you're saying. Got you. Did my graph the way I did it, did it not, it didn't start at zero this time, did it?
No.
My graph before the break, I started at zero. This one, I decided to shift it to the left and it gets started over there. So we gotta be careful. It stopped at 3 pi over 2. Where did it start? Negative pi over 2. They won't know this length. This is going to be considered your period of that graph. So every length, whatever that length is, it repeats values. You guys, it stopped at 3 pi over 2, the way I sketched mine. It started at negative pi over 2. If you take the ending of the cycle that I did here and subtract from it the beginning, I started mine there, you're going to end up with 4 pi over 2, better expressed as merely 2 pi. So I'm going to accept that as my period number. Every 2 pi things repeat. Okay. Amplitude, I think I used that word last time, and the description for amplitude was in your textbook the highest point from the axis.
No.
There is none. Goes on forever. So this graph has no amplitude, period 2 pi, range, domain with Fourier help, and there's the way the graph works. Guys, I'm pleased. We got 4 of the 6 done. What's missing? Tan and cotan. Yes.
So I know how later we're gonna do translations on them. So I was wondering if we have in the beginning there would be a number, like in front of second there would be a number. Would that make the inside between like where the parent of cosine is? Would that make that area like bigger?
Beautiful. Are you talking about the number? Hang on. He's saying he's looking at the lesson for tomorrow. Are you telling me maybe if there's a number out in maybe 3 secant?
Yeah.
That's a vertical stretch. Now, what do you think a vertical stretch on a graph that looks like this, the blue, and you're supposed to stretch it vertically by a factor of 3? What might that do to these? You think it's going to narrow it down? That's what his question was. And a vertical stretch by a factor of 3 means you have to go through and multiply the y coordinates by 3. That's where you get a vertical stretch and then connect. Hang on to that thought until we finally get all this together tomorrow. Guys, we're okay here? Beautiful. Jeez, I did it. Okay, let's put everything away.